Hi everyone, this is Mara Morsi, and today I'm gonna talk about SRE in the age of AI. But first, let me introduce myself. My name is Mara Morsi. I'm the founder of Cloider, which is a one stop shop for cloud native infrastructure, which is providing scalable serverless Kubernetes clusters at the cost of cup of coffee. So give it a try if it sounds interesting for you. And I'm a golden cube astronaut. I worked in different companies in different sectors like VMware, Kareem, and dozens of companies from cloud ride hailing, flights and hotel booking, food delivery, social e commerce, banking, and fintech. Today's session is more about SRE, less about AI tools, because by the time this session is published, like most of the AI tools would be obsolete. So we will talk more about the engineering and the frameworks of how to pick the right tool for the job, etc. We all remember her movie when the movie came out. When was the movie released? In 2013. It was a sci-fi movie. Like we could never believe that this could be even possible. But today, all the, every single feature in the movie is now available, and it's like any user could use it with any foundational model. Like ChatGPT can do all those functionalities in the movie. Let's keep this let's hold this moment, let's keep this thought, because we will use it later in many examples. So we all remember the Google Gemini demo first time when they showed us the multi-model architecture and how amazing it is. As it turned out, all this demo was fabricated. Google edited the demo so much so it couldn't be believable anymore. But at the time of the demo, like it was like nothing before. It was phenomenal. But like after the people tried Gemini for the first time, it can't actually do the same things as it's showed in the demo. And Google admitted that they have modified they edited the video so it looks as cool as it looked. But for now, like all the capabilities of the video of Gemini's video is actually available right now. Like we could actually use AI to help us solving the same problems at the demo, and with no issue. By the way, this video happened like 2 years ago. AI is rapidly evolving, and even if it doesn't, like the things that wasn't even possible 2 years ago, it's totally possible now. So let's keep this thought as well. Also, I remember in 2023, I was in Google Cloud launch in Saudi Arabia, and then I found like I have seen a demo, like it's still not even possible for today. Like I just saw the demo, and there is no such a tool up to date that can do a similar stuff. What I have seen in the demo, they showed Duet AI. Duet comes from do it yourself. So, what Duet AI actually is, it's like an AI collaborator that provides help to users at all skill levels where they need it. So it's actually an IDE inside the cloud. It's also a plugin you can use in your code editor. It's a code assistant, chat assistant, virtual assistant, you name it. It could be anything. So what seen in the demo, it was like a floating action chat in inside Google Cloud, and the guy in the demo just asked it to generate Terraform templates for all the entire infrastructure inside his account in Google Cloud, and it has done it with ease. Next, it asked it to make some modifications on this infra and apply it, and it actually did it. But this is not the most dazzling thing ever. The thing when when my jaws dropped was like he asked it um, if there is like just scan the servers and find the VM instances which has critical vulnerabilities and batch it. And it scans the images and it batched it immediately. Then it asked it a very, very interesting question, which is like just scan the low and medium vulnerabilities and check if there is like if a hacker or an abuser try to use those vulnerabilities together, he can make like a critical vulnerability. And it found a few vulnerabilities that when they use together, it makes a critical vulnerability. And it asked it to fix it, and this was amazing. Like for the first time, I see AI can do stuff even most humans can't even do. So it was amazing. But for now, where is Do It AI? They killed it. Currently, they use Gemini, and it's not actually capable of doing what we have seen in the demo yet. But that doesn't guarantee that it's not even possible on the long run. Actually, it's totally possible, and we will see AI do many things like that in the upcoming future. So, like, this is why we need to keep this thought of the hair movie, the Google Gemini demo, like everything that is not possible today, or it will be there in the upcoming future. So, before we discuss how to use AI in SRE, we first need to know what SRE actually do so that we can put SRE into action, like put AI into action with SRE. So as the very term implies, the the SRE ensures the system reliability. They do some sort of automation and toil handling, etc. They do optimization, performance, and scalability, manage observability, the CI/CD, and define reliability goals like SLAs, SLOs, SLIs, time to detect, time to resolve, like the RTO, the RBO, etc. Like and those terms are a part of the SRE OKRs. Like this is the most important thing that SREs could do. Like you need to add some SLOs, and then you every quarter, every whatever, you need to like challenge yourself, make it better until you like achieve the highest level of reliability. After an incident happens and he gets involved in the on call, he writes the post-mortem reports, etc. So, like the SRE is its role and discipline, which is focusing on keeping systems reliable. This is the most important thing ever. So it's focused on keeping systems reliable, scalable, and efficient, especially in production. So, like as I said, as a very term implies, that like it's in the job title, reliability. So how come any sane person, like would you trust the AI with root access? So just imagine that you have a junior developer. Do you give the new joiners root access, or you give them like admin access from the first day? No. And just like it doesn't have to be a junior. Like just imagine you have a very talented senior engineer, and he knows the best about his job. Like he knows the everything about like he knows Kubernetes, he knows AWS, he knows everything about it. He's Terraform certified, AWS certified, Golden Cube astronaut, and whatever. So he knows the best about his job. Would you involve him in on call on the first day? Never. So, the senior engineers takes on average from 3 to 6 months in order to start getting involved with on call rotation. So, like we don't even trust humans with like root access and making changes on production from the first day. So how come we do that with AI? With people, like if you have a sensitive data, you are compliant with GDPR. You don't even write BII's personal identifiable information into the logs. So how come you would trust an AI to access all your data? When you have different teams, you give each team member least privileges. So how come you give AI access to everything into your organization? Like all those are the problems we might face when we give AI access to production. Also, some of you might say like we as developers use Cloud and it's perfect. It writes all the code we use. We do vibe coding all the time and it works. So how um, like how it's different from how SRE is different from vibe coding, because in the development, it's not the first stop. Like once you write the code, it's once you allow Cloud to write code. If it failed, it's a failed build. Nothing critical actually happens. No actual risks, and also there is a lot of safety nets yeah, along the way. For example, you have a that you test it locally first and you review the code. There is a QC involved, there is a code reviews, and there's a lot of tools that checks the security and everything. So it's totally different. You because you have a lot of safety nets when you do vibe coding, but you don't have that when you give AI access directly to production. So, and if this AI has done any issues, who's accountable for that? Like, if if Claude did an issue while writing code, actually the responsibility of the code is the responsibility of the developer. So you are the one who's driving the AI to do this task, and you are totally responsible of the final result. So your job is to review the code that has been done by the AI along the way to production. So you are totally accountable for that. But if an AI agent has access to the infra, root access to the infra, and it has something wrong, like it's like you can't actually make the SRE engineer accountable for that because he wasn't even involved in the operation. So also, what if the AI has done a security issue related to roles, permissions, whatever? Like he added hard coded stuff in the configurations. It caused some security leaks or whatever. So like there is so much issues we need to resolve before using AI into production. So after all of that, like it reminds me in Better Call Saul when Chuck said to Jamie, like, Slipping Jimmy with a law degree is like a chimp with a machine gun. Just imagine a chimp with a machine gun. So no wonder when Netflix named its tool, it named it its tool for chaos engineering. It named it a chaos monkey. So it's a chimp with a machine gun. So like if you need to test any case engineering tool, you could actually like instead of doing so you could actually use AI for that. So again, what is the main issue? Like what is the issues that is preventing us from using or using AI in production? As a matter of fact, it's clearly a trust issue. So how to solve it? Like let's go back into 2023 and the Chat GPT era, and you might say that I'm an SRE. I will be in control of everything. I will make the AI just a read-only agent that I could use for only diagnosis, analysis, etc. And also for generation part, like as like it can handle everything for me, like writing bash scripts, Terraform modules, CI/CD pipelines, alerting, monitoring tools, Dockerizing apps for Kubernetes manifests and help and customize templates, etc. However, like when you think of it, like what do we actually call all of this? We call it toil. So there is a problem with that. Like even if AI is like helped you to be 5 times faster, it wouldn't fix the issue. Okay, but first, what is a tile? So the tile is a repetitive manual operational work that doesn't create long-term engineering value. So, like, you might be saying, like, when I do a bash script or when I automate stuff, this is a value, but it doesn't actually add the engineering value. So by saying that, for example, if you have a bot that has like out of memory issues or the body that you keep restarting for like having heap memory exceeded or connection pool connection pool exhaustion or whatever. So when you keep restarting this pod, it doesn't help you like resolving the real root cause of the issue, but the engineering does. This is what actually engineering value usually comes from by reducing future failures, improving scalability, redesigning weak systems. That's what you get when you focus on engineering. So basically, toil is running the system, maintaining the status quo, but engineering work is improving the current system, which makes all the difference. So here is the concept that if we used AI as an SRE for as a force multiplier, so let's assume that AI can make the toil handling can make toil handling is 5 times faster. So you will be doing this 5 times faster, which is great, but it's still not gonna solve the issue. So, uh, like, it, like at any healthy environment, Google recommends the toil that it should be less than 50%, and for healthy teams and healthy environments, it should be around 25%. So what Google says that even if you have used if you used AI as a force multiplier and it increased your efficiency to 5 times, so you became 5 times more efficient at handling toil. So what you will be gaining from engineering enhancement, it's only gonna be 26%. So you must be saying, no, what this is insane, this doesn't add up. So how come being faster 5 times would only make it increase the engineering only 26%? Let me prove that to you. So, what Google says is that you have a mathematical ceiling. So, let's assume that you are in a healthy environment and you are working like 20% of your time on toil handling, and AI made you more efficient. So instead of spending 25% of your time handling toil, by the help of AI, now you spend only 5%. So, like, it speeded up your time handling toil. So you will gain in return, like 20% more added up to the 75%, and now you will be handling 95% engineering. So in order to calculate the enhancements that has been done in engineering, you will take the uh, new value minus the old value over the old value, and you will get 26%. So what what that means is that even if AI makes toil handling 5 times faster, the total productivity gains in engineering, the improvements or enhancements, it's still gonna be limited by this mathematical ceiling. So, like, instead of investing more time, like with AI, yeah, like most of AI is trying to solve this issue, which is actually already been solved. Like, most of AI tools are good at generating code and doing automation and so on. But what we actually need from AI to help us doing is this 95%. Like, this is what we need to focus about. But now we are back in the square one. Like, would any sane person put AI in production? And it turns out there is Google. So let's see, the like, from now on we will take the journey to get to know how Google managed to run AI agents in production with a very, very minimal side effects. So, do you remember this book, The Bible of Site Reliability Engineering, by Google, which contains different articles about how Google runs production systems? There is a second edition. Unfortunately, it's not published yet. It's you can't actually order this book right now, but like, by the time you watch this video, you might check again. But currently it's early, it's in an early release. You can't, like, it's not even in Google's website. It's not even like, you can't order it or pre-order it. So, like, check again. You might be able to see this book. However, the second edition of this book contains new 4 chapters, and one of them is about how Google use AI agents in production, which is a very, very interesting topic we will discuss right now. But before doing so, let's ask a very, very simple question. Why do we want to introduce AI to SRE? Are we like, why would any sane person is trying to make the SRE job less reliable by using AI? So, uh, unfortunately, you have to use AI for a couple of reasons. The developers are shipping code faster than ever before. The systems are getting more complex. The cognitive load to keep these systems running becomes a major reliability risk by itself. And all other businesses are using AI, and we don't want to be left behind. Also, we hit the ceiling of what automation can solve at production. This is why we need a new players to help us solving different novel issues. So let's see like what we have been and where we are going, because this will help us like knowing how AI could solve a completely new kind of issues. So just imagine this is a monorail and it's like anything like this is your bash script. Just imagine it as your bash script. It's totally deterministic. It's the traditional way of automation, and the tasks has to be has to be already known before you automate it. You can't automate stuff without actually knowing the issue first. So it's deterministic, but like if anything went wrong with bash script with the deterministic approach, it stops. It can't resolve issues by its own. It has to know the issues already previously. So we need uh, a new type of automations that can help us resolving novel issues. So just imagine the self-driving car. Um, this is where we are going with AI. So the AI is probabilistic. It adapts to the messy, unstructured context, and it takes a best guess based on confidence intervals. So, like, there is it adapts um with different events along the way. So it doesn't need you to actually rewrite the bash script every single time you have a different issue on production. So this is why we need such tooling that could help us resolving novel issues, which is completely issues we have never known before. We might even never notice that it even exists. So, like Google defined a roadmap to have a fully autonomous SRE AI systems, and those are the steps to that I will explain along the way. So first of all, the paradigm shift. Like in order to start adopting AI in production systems, you can't just sprinkle this AI on top of what you currently have right now. Like you have to start with changing your mindset. Like you are currently moving from rules to reasoning. So in before even the AI touches your production, you have to prioritize the foundational elements like psychological safety and situational awareness. I will explain them in the next slides. So the psychological safety and trust. So before like now we have like ensured that we changed our mindset. We started like working on the psychological safety and situational awareness. As a part of psychological safety is that we have to keep human in the loop, like by having a lot of transparency. Like, I will explain that later, but in the development, AI, if it messed up, as I mentioned previously, it's totally fine. Like, there is no risk of that. But if an SRE agent has done a mistake, it could be accidentally, like it could accidentally drain totally healthy clusters that hits real users and real revenue, and also reputation. It could affect the reputation of the company. And we all know about the GitHub issues, security issues, the reliability issues previously. They are not in the best shape recently. So when this affects the reputation of the company loses a lot of customers and a lot of revenue as well. So we need to we need to have a rigorous guardrails before we put AI into production. The first guardrail is adopting or having transparency. Like the AI has to explain everything, its reasoning and confidence level in real time. So this is very, very important in order to know how AI took this decision, and like in order to evaluate it later in case if it has done something wrong. Um, Also, it has to have the contextual awareness, and this is what makes people unique. Like, for example, as an action which is totally safe in Tuesday in the morning could be an actual catastrophic. Could be actually catastrophic during a huge peak traffic event. Also, this is what I have been talking about, the tribal knowledge that you get as a human operator, as a human SRE engineer. Like, for example, there is a service called payroll. Like, if you know the business, you know that it's totally fine to restart the service, like in the middle of the month, but it's not acceptable at all to restart it at the end of the month. So, like something like that, this is what prevents SRE engineers from like being on call once they join the company, even if they are totally capable technically to do stuff. So the AI agent would know Kubernetes as like the Kubernetes is the best. Like it got trained on the Kubernetes documentation itself. So it memorized documentation by heart. So it's not a technical. It doesn't have any technical limitation. But the tribal knowledge, the knowledge that you have gained about the business, about the conventions you as a team agreed on, this is what uh, like what AI would be missing out. So the AI, in order to run on production, it has to have a contextual awareness, and I will talk about contextual awareness in the upcoming slides. So, also, in order to run the AI in production, it has to have a progressive authorization. So the trust must be earned. So the AI must start with read only access and just to be used to diagnose stuff. And it has to earn trust before it could actually propose, execute actions. Also, we need to have a break glass mechanism. Like, we have to have a big red button to immediately cut the access if the agent goes wrong. Also, like the guaranteed reversible operations. The AI cannot take actions unless it knows exactly how to undo it instantly. So, every deployment has to have it has to have a rollback. Every action every operation on the database, it has to have its rollback operation. So you must implement before allowing AI to take any action on production, you have to guarantee that this AI has reversible operations. And actually, like, this is the most important slide ever. So I encourage you to take it as a screenshot. Like, you might need it to evaluate any upcoming AI tool, because like this is what the AI tools should follow. Like, this should be the framework, the like what the AI should have in order to have to implement the psychological safety and trust before you run AI agents in production. Um, the the next step is by adopting awareness and detector, and which means we need to move from metrics to meaning. So the pre-AI detection systems are completely blind to novel issues. So traditional monitoring systems aren't, like, you might have an issue, everything is green, and traditional monitoring systems aren't even blinking. So just imagine this scenario. For example, you have an error rate with 0.1 percent. So the like 0.1% error rate on a dashboard, in aggregate, this looks totally green and healthy. Like, if you have zero point 0.1 error rates, that means you have 99.9 percent success rate, which is amazing. But what if that error rate is actually 1% of your customers failing 10% of the time? So just imagine that you have 1 million requests and you have 1,000 failed requests, which means this error rate. But you have 10,000 customers, and 10 customers, which represents 1%, are affected. So those 10 customers are failing 10% of their requests. So the platform view, your dashboards, your Grafana dashboards, are showing 0.1 error rate, which is amazing. However, the actual affected customer view, like the what the actual users are really experiencing, is 10% errors, which is terrible. So, like, so Google has developed an AI system, like, it's called the detector, and this detector pipeline is an ML ops pipeline, which starts by augmenting the internal system state data to user feedback. Do you remember this in do you remember this survey with every product? So Google has noticed that not all issues can be known from their internal systems. Internal systems like the traditional, traditional observability systems like log metrics, traces, events, and also the support tickets. It's still not it's still not having the full picture yet. So they made an AI system that collects the data from logs, metrics, traces, the support tickets, and from the events and from the social media as well. Like like when companies doing sentiment analysis, it's like Google is collecting those data as well, and they have an AI system and a machine learning pipeline that is doing augmenting for this data. It collects all the data from the different systems and send it to the LLM filters that is removing irrelevant posts and categorize the data. Next step is embedding an LLM clustering. So basically, they are grouping the the data by semantic meaning. So basically, like it's grouping related reports together to identify potential outages. And next step is generating the LLM report to like it generates a structured, actionable outage report and notifies the appropriate team. So this is a tool that has been developed in-house in Google. So Ruslan Mischenberg, the VP of Site Reliability Engineering at Google, is saying that the revenue saved and reputation of reliability upheld by using detector cannot be overstated. And actually, like the detector is on a clear trajectory to become used universally across all Google orgs. Um, so the detector had a very success story in Google, and it saved thousands of cumulative hours for customers. Help detecting novel issues versus the traditional monitoring systems, and it mitigates problems before they spiraled out of control. So the next thing is resilience and infra, which is basically eliminating manual toil. But before that, like we need to distinguish between two very important stuff. So now when an incident happens, we lean on AI to help out, but we need to draw a hard line between mitigation and root cause analysis. So mitigation is like basically to like it's all about the speed. You have an issue and you need to take like the highest confidence predefined safe action in order to fix it. But the root cause analysis, like if you have something, you could add bandage, but if you really, but root cause analysis will tell you why this hole even exists in the first place. So the AI, like dives deep into observability data and topology maps to start generating hypotheses, and it traces anomalies all the way back to complex distributed systems. So, in order to eliminate the toil, AI capability is way beyond reacting to incidents. Like it's not just about eliminating toil. Like it could help us way more than that. It can generate auto generate incident reports. So just imagine that SRE humans are finally free to discuss the lessons they learned instead of wasting time for formatting timelines in a document. Uh, to have dynamic views, like for example, during incidents, it can generate or tailor a dynamic dashboard on the fly showing the specific historical graphs that matter right at this second. For example, uh, uh, all of us have experienced similar issues when you are on call. When you have an issue, you open like 50 tabs, one for each dashboard. But now AI could like detect the issue and show you dynamic dashboards that are totally relevant to the current incident, so you don't even have to check another tab. So AI can help you to intercept duplicate tickets and handle the help desk tickets. It could autonomously execute standard runbooks. So instead of having a runbook and you do it every single time manually, it can help you implementing this runbook with high confidence. It could also do very advanced engineering topics, like it could review and draft complex resilience task plans. The fifth thing in this roadmap to adopt AI in production is following the five levels of autonomy to have emergent reliability. So adopting AI is not just flipping a switch from off to on. It has to be very carefully structured progression. So you should start from level zero, completely manual, except you might have automatic monitoring and alerting, to the level five, which is sorry for that, to the level five, which is totally fully autonomous. So the path to autonomy is for having a fully autonomous self-healing system is to follow this maturity model. You start with level one all the way to level five, which is the level one is basically you depend on humans on everything, doing everything. Level two is to use humans with monitoring. Like everything is manual except you have monitoring and alerting. Level two is you use AI but as read only, and you can use it for diagnosis, analysis, and investigation. And level four is that you make AI have hypotheses and suggest taking actions, but it requires approval from you as human before taking the action. Uh, Also, the level four is completely autonomous, but it's tightly bounded for low risk scenarios. Like it only executes actions with a very high confidence. But if it if it's not highly confident about the action, it would then take it, and it will require approval from human first. Level 5, which is achieves the fully autonomous self-healing systems, and this is completely autonomous. AI is doing everything, including doing complex planning as well. So, the the operate Google has an AI operator. Let's see this AI operator in action, which implements the autonomy framework. So it's mainly based on earning trusts, earning the AI trust. So basically, the AI has to be the first one on the scene when the alert goes off. And level one is to have AI to assess the on-caller person. So it provides on-caller with immediate context and diagnostic path. So and it's correlating signals to give human engineers a head start. So it basically when an incident happens, it starts investigating and gathering all the facts for the human to take an action. The second level, which is partially automated, which basically proposes concrete actions for human review and explicit review. So it basically makes the hypothesis and tries to take an action and waits for your review. Once you approve, it will take the action immediately. The next step is to have this system autonomously handles specific, well understood, low risk, high confidence scenarios, which is this is actually a totally acceptable system. And currently, there are couple of there are many tools are doing so. Like most observability tools which have root cause analysis, there are specific startups that are based on resolving issues with level 3. We have Incident.io, Resolve.ai. We have a lot of tools and systems that are capable of resolving those issues on level 3. However, level 4 is achieving the full autonomy, which is basically managing complex end-to-end tasks without human review or approval. So, how to get there? How to get to the level 4? Basically, in order to for the AI operator to get better at its job, it needs some sort of a feedback loop. This feedback loop, it evaluates its own actions against golden data. They get those golden data from ideal human response to the exact same incident. And if this system correctly diagnoses and mitigates the issues, this is great. But if it fails, this feedback loop kicks in and it critiques the agentic logic, points exactly why it failed, and proposes refinements to its prompt and reasoning. It's constantly learning and self-correcting from every single iteration. So this feedback loop is called LLM as a judge, which evaluates outcomes against ideal human response to refine logic over time. So it basically the this is the SRE agent that takes the actions. After taking the actions, it sends it to the LLM as a judge model, which basically checks if it's done its job fine. This is great. If not, it it like evaluates this action against the golden data, which is the ideal human response, and then it understands what happens, what went wrong, etc., and it critiques and refines the model, changes the correcting the model. It could actually update its prompt and refine its reasoning. So and by having some sort of feedback loop, the AI is always getting better and better until it reaches this level 4 to have a fully autonomous self-healing AI system in production. So we have to change our mindset to adopt AI in production. Like the AI is gonna do basically most of the work, but and we need to augmenting humans in the process. So after all of that, will AI replace the SREs? So, what Google says that organizations will demand higher reliability across a broader a portfolio of services, increasing SRE scope. So, since the AI will be we will use AI a lot of in different systems, which will make us way efficient and faster, and the AI will be way cheaper in the future. Like as every economical stuff, like when something gets adopted quickly, it will be cheaper in the future, like any technology. However, this just doesn't justify that that AI will not replace SREs. Like as it happens today, like AI has already taken so many jobs, and like instead of for the company to hire 10 different SREs, like two SREs will be totally enough by the help of the AI. So I don't think that what Google mentions is 100% correct. And they say that when you have the SRE, you will move to the next harder problem, which is which is true. So Are you ready to let AI take the wheel? So um, let's let's have a quick recap. We have covered a massive shift today, like from non from deterministic systems to probabilistic systems. We moved from brittle deterministic scripts to highly aware probabilistic reasoning AI agents, building psychological safety, progressing through infrastructure autonomy levels using rigorous feedback loops, moving SRE from just reacting to failures to engineering systems that are truly reliable by default. So, like, uh, right now, you can't, as I mentioned previously many times, that you can't just add AI on top of current existing systems. And in order for you to adopt using AI, you can start taking one small action at a time. For example, if you need to have all different types of documentation, like you need to keep working on documenting everything, like having post-mortem reports. You need to have run books for every action you do on production. You have to have documentation about the internals and ins and outs of the current existing system. Uh, and once you have this, uh, you can start adopting AI in the loop. But like by sprinkling AI on top of existing system, you can just do it in one day. You have to pave the road first before having AI systems. So. Yeah, that was it. I really I have really enjoyed um, having this session, and you can always contact me on LinkedIn by Mara Morsi. And thank you for watching.